So in this video, we're going to solve the given differential equation by using an appropriate substitution. So the dA is homogeneous. So we'll write that down here. Y dx is equal to 2 times x plus y dy. So a first order differential equation is said to be homogeneous if we can express our differential equations of this form. Dx over dy is equal to some functions f in terms of x over y. So similarly, we can also have dy over dx is equal to some function g of y over x. But we're not going to use this one. We're going to use this one here. So we'll make a way to make our differential equation have this function on the right hand side of the equation, like this form, f of x over y. So let's go divide both sides of the equation by 1 over y dy. So multiply 1 over y dy times y dx. We can cancel y here. So we'd be left with dx over dy, and our left hand side of the equation is equal to multiply 1 over y dy times this one. You can simply cancel these out. So you'd be left with 2 times x plus y over y. Now we're closer to having our function in terms of x over y. And how do we do that? We separate x plus y over y. So this can be decomposed by making this denominator have here x over y plus y over y. Okay, y over y is just 1, so we can actually make this 2 times x over y plus 1. See, we now have a function in terms of x over y. So the next thing we're gonna do is to let some variable v is equal to x over y and take the derivative of dv over dy. But this can be rewritten as x is equal to vy, right? So solving for the derivative dx over dy in terms of y, so this is now dx over dy is equal to the derivative of our product dv over dy times y plus dy over dy times v. Okay, so we now have dx over dy is equal to y dv over dy plus v. But our dx over dy is just this one, 2 times x over y plus 1. But our x over y is v, so we change everything, the x over y, to v. So we now have 2v, 2 times v plus 1. Okay, so let's go solve for dv over dy so that we can easily integrate y. Let's go right, dy dv over dy is equal to, we can subtract v from both sides of the equation, so we'll now have this one cancel out, so we'll have this remaining, and this is 2 v plus 1 minus v. So that's it. Subtracting v from both sides of the equation is like this. So we now have y dv over dy is equal to 2v plus distribute plus 2 minus v. It's just 2v minus v is just v. So we have v plus 2. So y dy dv over dy And the next thing we're going to do is separate the variables. All of the variables contained in y on the right hand side of the equation, and all the expression contained in v on the left hand side of the equation. So we can actually divide dy over y times v plus 2. Let's go delete this. Okay, so y dv over dy times dy over y times v plus 2 can cancel y and dy. So we'd be left with dv over v plus 2 is equal to this one here, multiply to this side, v plus 2 times dy over y times v plus 2. We can simply have dy over y. Now, it's easy to integrate both sides of the equation using the logarithmic integration. So we'll just move dy over y here is equal to integral of dv over v plus 2. So we have integral of dy over y is equal to integral of dv over v plus 2. So this is just ln of y is equal to ln of v plus 2 plus any constant c. But remember that our v is equal to x over y. So we'll plug that in back here, this one here. So ln of y is equal to ln of x over y plus 2 plus c. Now we have our answer. And this says it's correct. So thank you for watching my video.